recall for me what we've been learning about with fractions the last few days. Well, last week, today's Monday, but Landon, what's one thing we've been learning about?
Benchmarks.
Benchmarks is one, so great. Olivia, give me another one.
Equivalent fractions.
Equivalent fractions, love it. Rory, what's another? Were you thinking the same as Olivia?
Yeah, I was going to say equivalent fractions.
Well, that's awesome. Harper,
Reducing fractions.
reducing fractions. What are you thinking, Blake?
Comparing fractions.
Comparing fractions. Cole, do you have something different?
We learned more about like it's kind of reducing more into like kind of like reducing fractions, like the ladder, like how to.
Oh yeah, different strategies, right? So we talked about a lot of different strategies of. You guys learned a new strategy for reducing. Some of you like the ladder method. Then we talked about different strategies we can use to compare fractions. What are some of those strategies and tools we can use to help us compare fractions? What are you thinking, Jesse? Cross products, a favorite. Jeremiah. What's another strategy or a tool that we can use to help us compare fractions? Harper.
To compare fractions, the bridge.
The bridge. Okay, so yeah, you can think about making equivalent fractions, right, and see how you can compare them. Like if we use our benchmark for 1/2, right, and we can compare by thinking, okay, and what's the equivalent for fourths for a half? 2/4, right? So you can think, okay, I'm going to make a bridge to be able to compare fractions with fourths, right? Good. Any other ideas? I know there are a couple of you that love a tool that you have on your desk right now.
Fractions.
Rory.
Fractions.
I know Rory loves her fraction strips. That's another example of a tool that we've been using to help us find equivalent fractions, to how to reduce fractions, and how to compare fractions. Very good. So today, I have a little story for you. It is about two adorable little polar bears named Klondike and Snow. And throughout the book, it talks about the story of their life and how they were raised by zookeepers, but it also talks about fractions in the way that it talks about how they would the fractions of what they would use to make their food to feed them, and it talks about their weight in terms of fractions, like how their weight compares to one another. So we're going to read their story and get to learn about them, and then I'm also going to be connecting our knowledge about what we've been learning with what the book talks about with fractions as well. Okay, so polar bear math, learning about fractions from Klondike and Snow. So here's some cute little pictures of them when they're babies.
I want that one. And that one.
They're pretty cute.
And that one. And that one.
They're pretty adorable. Okay. Early one November morning at the Denver Zoo, a polar bear named Ulu gave birth to two baby bears. She cleaned them off, then left them lying on the cold cement floor of the hallway that led to her den. When Gary, the polar bear keeper, came to work, he heard soft crying. Gary could see that Ulu was in her den, but there were two small shapes in the hallway. When he looked closer, he found the newborn polar bear twins that Ulu had abandoned. Gary tucked the babies inside his jacket and rushed them to the zoo hospital. And this caption of the picture says, Ulu, like 2/3 of all polar bear mothers, have twin bear cubs. So let's take a look to what we can learn about mother polar bears over here. So this gives us the definition of fraction. So I'm going to say it first, and then I want you to repeat after me. A fraction is a part of a whole, or a part of a group, or set.
A fraction is a part of a whole or a part of a group or set.
Very good. Here is a set of animals, 3 mother bears. Each mother bear is one part or one fraction of the set. So here we can see they show us a picture of 3 mother bears. And then down here it says the total number of equal parts in a set is always on the bottom part of the fraction and is called the denominator. The number of parts you are dealing with is always on the top of the fraction and called the numerator. So tell me, friends, what's the denominator? Brady.
The one on the bottom.
It's the number on the bottom, right? And what does it tell us? So it tells us the total number of equal parts, right?
Yeah.
So it tells us if we cut a pizza into 6 pieces, how many pieces do we have total? 6, right? So the denominator tells us the total number. And then what about the numerator? What is the numerator? Olivia.
The numerator is on the top.
on the top of the fraction, what does it tell us?
Like sometimes it's like how many pieces of something are like shaded or something.
Perfect. So like it says here, the number of parts we are dealing with. So the denominator tells us the total number of parts, like the total number of pieces of pizza, and then the numerator tells us how many we're dealing with, like if Billy ate 4 pieces of the 6 pieces of pizza. So what fraction would that be? 4/6, perfect. On average, 2 out of every 3 mother polar bears have twin babies. We can show this with the fraction below. In this fraction, the denominator is 3 because there are 3 bears in the set. And the numerator is 2 because 2 of the bears in this set have twins. So it shows us a little diagram. Numerator over denominator is equal to the mother bears with twins and all mothers in the set. And then it shows us how many mother bears on average have twin cubs from what this diagram shows us.
2/3.
2/3. So 2 out of every 3 on average mother polar bears have twin babies. Of the 3 mother bears, 1 does not have twins. We can show this with the fraction below. In this fraction, the denominator is still 3, but the numerator is going to be what? 1. And because that is showing us that 1 bear does not have twins. So this shows us a diagram just like up here, but it's the opposite, right? So this showed us mother bears with twins. This shows us the mothers who don't have twins. So 2/3 of all mother polar bears have twins, while 1/3 of all mother bears do not have twins. Excuse me. So this next page says common denominators. Fractions that have the same denominators are said to have common denominators. It is easy to add fractions if they have a common denominator. You can simply add the numerators. The denominator does not change. So it says, it is easy to add fractions if they have common denominators. You can simply add the numerators. So that's not something we've worked on yet this week, but that's something we've talked about before, right? That when we add fractions, we just add our numerator and the denominator stays the same, right? So here we go back to the diagrams we had on the last page, and it's adding the 2 fractions together. So how many mother polar bears have twins again? What fraction? 2/3, very good. 2/3, and then, so how many would not have twins? 1/3. So it's showing us 2/3 plus 1/3 equals 3/3, and it's showing us that the 2 are equal. So if we added them together in whichever order, they would both be 3/3. And then it shows us down here numerically. 2/3 plus 1/3 is equal to 2 plus 1 all over 3, because does the denominator change when we add? No. And then it equals a total of 3 out of 3. In the resulting fraction, both the numerator and the denominator are what? 3. When the numerator and the denominator are the same, the fraction is equal to what, friends?
1 whole.
1 whole. So whenever, no matter what the denominator is, if the denominator is 3 or if it's 712, if the number is the same on the top and the same on the bottom, it's equal to what?
1 whole.
1 whole, no matter how big the number is. So it's showing us here that all 3 mother bears is equal to 1 set. So out of 3, like we've been talking about. Because the cubs were very weak, Cindy fed them sugar water at first. Soon they would need milk. But what formula would be just right for polar bear cubs? Cindy did some research and learned that polar bear milk looks like heavy cream, smells fishy, and is high in fat. Does that sound very appetizing? No. Thank goodness it's for polar bears, not us. When zoos have to make milk for a baby bear, they use puppy milk formula because it's most like a mother bear's milk. So Cindy mixed puppy milk with half and half, which is half milk and half cream. Do any of your parents use that in their coffee or anything? Yep, my dad does. So she added the half and half to add extra fat into the milk to help the babies gain weight. And then she added cod liver oil and vitamins. Why do you think they added cod liver oil? What is cod, Callie?
It's a type of fish, and
like fish in it, so they added the cod liver.
Right, so what do polar bears, like grown polar bears, eat?
Fish.
Fish, right? So I imagine that my prediction would be that the fish that the mom eats is really important in the baby's diet too, because it adds different vitamins and minerals. So they wanted to make sure that they got that for Klondike and Snow too. Okay, so this page is going to tell us about how they made polar bear milk using fractions. Cindy used a recipe to make polar bear milk. She mixed 1 cup of puppy milk with 2 cups of half and half to create a whole amount of 3 cups. So by looking at this, just these pictures here, what fraction would the puppy milk be?
1/3.
1/3. How did you know that? Somebody raise your hand. Olivia, how did you know?
Because there were 3 whole cups, and one of the cups is the puppy milk.
Perfect. So she said, I see a total of 3 cups, and I know one of them is puppy milk, so it's going to be 1/3. So if the puppy milk is 1/3, what's the fraction of half and half going to be? Out of gate.
2/3.
2/3. Perfect. So 1 cup is puppy milk, so that's 1 out of the total of 3, and then the other 2 are half and half, so that's 2 out of 3. Perfect. Since the whole amount was in 3 equal parts, you could say 1 part, or 1/3, was puppy milk, and 2 parts, or 2/3, were half and half. After the milk was mixed, cod liver oil and vitamins were added, so just like it talked about on the last page. And again, this is showing us how we can add those fractions. So 1/3, what fraction was 1/3 again, friends? Or what part of the milk was 1/3? The puppy milk, right? So the puppy milk, and then what was 2/3?
The half
Half and half. 2/3 equals the total of 3 parts out of 3. And that equals 1 batch of polar bear milk. At first, the cubs needed to eat every 2 hours or 12 times a day. Dr. Kinney, Cindy, and Denny, another veterinary technician, took turns bringing them home at night. Every 3rd night, it was Cindy's turn. At 5 o'clock, she put the 2 bears into a box padded with fleece to keep them warm, packed lots of bottles of milk, loaded the cubs, their food, and a portable incubator into her car. Once home, she unpacked, made dinner, then fed and cleaned the bears. Snow was no trouble. She drank her bottle and went right to sleep. But Klondike screamed a lot. So there's the 2 bears in their little incubator that they used to keep them warm. So this gives us a little diagram that shows, because we had a total of how many days in the month? 30. And then they each took the bears 10 days each. So that is an example. If we started with the fraction, what would be our fraction if we looked at the number of days? So how many days did they each take them?
10.
And then what was the total number in the month?
30.
That would still.
How did they get to 1/3? How did they get to 1/3? Billy, how did they get to 1/3?
They just took away the 0.
Okay, so they did that. How would we do that? So think about what we've learned this past week. We would reduce. So to get rid of the zeros, what would we reduce by? Cooper? 10. So, like we said, we can kind of build our bridges with division, right? And divide by 10. So what's 10 divided by 10?
1.
And what's 30 divided by 10? So that is how they got from the number of days each of the doctors took the bears out of the total number of days in the month, and then they reduced to get 1/3. Very good. After 2 weeks, the cubs' weight had doubled. Raise your hand if you remember what their initial weight was. Let's see, blank.
A little over a pound.
A little over a pound. So if it had doubled, how much would they weigh now? 2 pounds. Very good. So cute. Okay. 12 and thirds. When Klondike and Snow were 2 weeks old, they each drank 12 bottles of milk in 1 full day.
Oh my god.
Since one bear's daily portion of milk, the set was 12 bottles. Each bottle was 1/12 of the set. So it shows us that they drank how many bottles during the day, friends? 12. And so 1 bottle would equal what fraction? 1/12. The chart below shows that 1/12 is a smaller fraction than 1/3. When the denominator is a bigger number, the whole amount is divided into more parts, so each part is smaller. When the denominator is a bigger number, the whole amount is divided into more parts.
When the denominator is a bigger number, the whole amount is divided into more parts.
Great, so each part is smaller.
So each part is smaller.
So we've talked about that, right? And we can see it perfectly with our fraction strips when we lay them all together. We can see that the 12ths are a lot smaller than like the thirds, right? Because they're cut into more pieces. Very good. You can also see that the fraction 4/12 is equal to what in thirds? 1/3. These two fractions are called what, friends? Equivalent fractions. So down here, it almost shows us like our fraction strips. So we can make that connection that you guys have worked with fraction strips, and these are a demonstration of fraction strips. How you can compare 12ths and thirds. So again, how many 12ths are equal to 1/3? 4, perfect. So how many 12ths would be equal to 2/3? 8. And then what about 3/3? 12, perfect. Sometimes Snow acted like she was in pain, crying out between feedings. She didn't like it when Klondike touched her. Cindy began to worry that Snow was too quiet and inactive. Dr. Kinney took x-rays of the bears. The x-rays shows that both bears had tiny breaks in many of their bones. Klondike and Snow had a disease called rickets. So based on what the book just told us, if they took an x-ray and they had many breaks in their bones, and then they said they had a disease called rickets, what do you think rickets is? Just making a prediction. What do you think, Ruby?
The bones break from the least, it's like little bones thing.
Mm-hmm. Yes, that's
way easier.
Yeah, that's exactly what I was thinking, making that connection to a human disease, which is called brittle bone disease, which like Ruby said, they can either break for almost no reason or something really small, like someone can tap you and it breaks a bone, because your bones are just so fragile. So that's what I was thinking exactly, Ruby, that it sounds like they have it, but it's like what it is for animals, like polar bears. 8ths and 12ths. By the time Klondike and Snow were 1 month old, they drank more milk, but they were fed less often. In a full day, each bear drank 8 bottles of milk. How many bottles of milk did they drink in a day? 8. For each bear, the whole amount or set was 8 bottles. So 1 bottle was how much? 1/8 of the set. And then down here, it says you can see on the chart below that 1/12 is a smaller fraction than 1/8. So it's kind of like our comparison on the last page with thirds. But let's take a look. How many, by looking at this diagram, do we have a fraction of 12 that's equivalent to 1/8?
Yes.
Do they match up exactly?
Yes.
Not quite. So we can see that here's 1/8, and then here's a 12. So so it cuts it right in the middle, right? But what about 2/8? Do we have an equivalent fraction of 12?
Yes.
What is it?
3/12.
3/12. So we can see that they're cut in the same amount. So 3/12 are equal to 2/8. So making more of those connections of our fraction strips that we use and how we've talked about comparing fractions this past week as well. So it shows a little picture of them playing together and it says, who says it's bedtime? I don't know about you, but I think if I were Snow, I'd be kind of irritated that my brother was crawling all over me all the time.
And
I'd probably be
burrowing
like,
underneath.
I know, like burrowing underneath me.
Like, I feel like that's what my little sister does. She's like,
Yeah, as if being on top of her wasn't enough, he was like, if you won't let me on top, I'll go underneath you. So again, let's make a prediction. It says, since Snow had been growing faster than Klondike, so since Snow had been growing faster than Klondike, her bones were more affected by the rickets. Good, so let's make a prediction. Why do you think if she was growing faster, why was she more affected by the rickets? So think about it for a minute, and we're just making predictions. So no wrong answers, just thinking about why we think that if she was growing faster, her bones are more affected. What do you think, Harper?
It may be because she's growing faster, that her bones need more, like, she can't support as much weight that she has.
Mhm.
Her bones can't support that much weight.
Yeah, I think you're exactly right. So if you're growing faster, but her body's not producing enough vitamin D, then like you said, her bones can't keep up, right? So it can't keep up with, she's getting bigger in her weight, she's getting more fat on her body, but her bones are not growing like are not growing as fast to keep up with the rest of her body growing. What are you thinking, Billy?
I have a question.
You have a question? What's up?
Our bearded dragon, we did not know that she needed calcium,
Mm-hmm.
so we have not been feeding her calcium with her earthworms.
Mm-hmm.
So then her arm was detaching,
Oh, wow.
and she lost her arm.
Oh, that's very interesting. So did you start feeding her calcium after that? So that's really interesting. Billy made such a cool real life connection. I mean, I feel bad. I'm glad your bearded dragon is better because it's not very good if, her arm is detaching from her body. But that's a great connection that you just made, that your bearded dragon had the same problem, right? That he was a boy or girl?
Girl.
A girl. So she wasn't getting enough calcium, so her bones weren't being supported, right? So you need to add some extra calcium into her food. That was a great connection. And then up here it shows Cindy feeding Snow. Making polar bear milk using halves. When Klondike and Snow were 2 months old, zoo staff decided the bears needed more protein in their milk to help them grow faster. The original recipe had how much puppy milk? See if you remember, 1/3. Because puppy milk has more protein than half and half, Cindy knew she had to use a bigger fraction of puppy milk in the recipe. So she increased the amount of puppy milk in the recipe to 1/2 of the whole amount. The chart below shows that 1/2 is it lesser or greater than 1/3? Bigger, right? So it shows us right here that 1/2 is bigger than 1/3, right? Cindy mixed 2 cups of puppy milk with 2 cups of half and half. So let's talk about the fractions here. So Cindy mixed 2 cups of puppy milk with 2 cups of half and half.
Cindy mixed 2 cups of puppy milk with 2 cups of half.
Good. Since the whole amount was in how many equal parts? We'll get our diagram. 4. So how many parts were puppy milk? 2. And how many parts were half and half? 2. And what is 2/4 equivalent to again? 1/2. So this time, instead of having it split into thirds, they split it into halves. So they used to have, was it 1 part puppy milk and 2 of half and half, so they instead started doing half of each. But the puppy milk is supposed to be 1/2 of the whole amount, not 2/4. So the chart below shows that, like what we just talked about, 1/2 and 2/4 are equivalent, which you guys knew that already. So after the milk was mixed, again, the cod liver oil and vitamins were added to help give them that extra nutrients they needed. Making polar bear milk using fits. Let's focus up, friends. Thank you. At 2.5 months, Klondike and Snow still weren't growing as fast as the zoo staff thought they should be. Cindy needed to change the recipe for bear milk again. She needed to use a formula that had more puppy milk than 1/2 of the whole amount. From the chart below, you can see that 1/5 is smaller than 1/2. This goes along with our rule that the bigger the denominator, the smaller the fraction. So the bigger the denominator, the smaller the fraction.
The bigger the denominator, the smaller the fraction.
Great. But when you add 3 of the 1/5 parts together, you get the fraction 3/5, which is bigger than 1/2. So again, it's making this comparison. So we see, just like, I love these diagrams that are just like our fraction strips, because you guys are familiar with that strategy and tool. So it's showing us that 1/5 is smaller than 1/2, but 3/5, which it sounds like is probably going to be the amount of puppy milk they start to use, is bigger than 1/2, because they said they need to grow the amount of puppy milk because they still weren't growing fast enough, right? So it says Cindy mixed 3 cups of puppy milk with 2 cups of half and half to make a whole set of 5 cups. So how much was the whole set again?
5 cups.
5 cups, thank you, Harper. And how much of it was puppy milk? How many cups?
3 cups.
3. So what fraction would that be?
3 out of 5.
3 out of 5, so 3/5. And then the other 2 cups were half and half, so what fraction would that be?
2 out of 5.
2 out of 5. Perfect. And then it just, again, says, since the whole amount was in 5 equal parts, you could say 3 parts, or 3/5 for puppy milk, and 2 parts, or 2/5 for half and half. And then it just shows us a diagram again about adding those together, just like we talked about earlier. When we add fractions together, the denominator changes, right? We add that together too? No, right? The denominator stays the same, kind of a trick question. See if you guys are paying attention. Says, what did they put in my food? So it looks like that's when they started combining the dog food with the milk, right? So 4ths and 8ths. At 3 months, the bears were drinking only 4 bottles of milk a day, though they also got some milk mixed in their solid food. So for each bear, the whole amount or set was 4 bottles, so 1 bottle would be how much?
1/4.
So the whole amount was 4, and so 1 out of 4 is 1/4. Oh no! There we go. So instead of drinking 8 bottles a day, or 1 bottle every 3 hours, as they did when they were 1 month old, the bears were now drinking 4 bottles a day, or 1 every 6 hours. From the chart below, you can see that 1/4 is a bigger fraction than 1/8. In fact, 1/4 is how much as big?
Double.
Twice as big as 1/8. 1/4 and 2/8 are what? Equivalent fractions. So again, we look down at our diagram, and it shows us that 1/8, because it's like we take 8 and divide by 2, we get what? 4. So that was that was a little confusing. So 8 divided by 2 equals 4, so we can see that 4 is twice as big as the 1/8, or 1/4 is twice as big as the 1/8. Now let's talk about their weight as adults. So again, somebody remind me, what was their initial weight when they were born? Add a Kate. Oh, if your name's not Add a Kate, repeat it again. A little over a pound. So let's talk about how much they weigh at probably a year old. So it says, Klondike loves playing with a pumpkin. So he's playing with a pumpkin in the water, which is interesting. Both bears grew a lot in their first year of life. During the next few years, Klondike grew much bigger than Snow. Adult male polar bears are usually bigger than female polar bears. When Snow was full grown, she weighed about 450 pounds. Your turn. Good. While Klondike weighed 900 pounds. So let's do a little bit of a prediction. So Snow weighed 450 pounds and Klondike weighed 900 pounds. What would you think about maybe a comparison of their weight? How do you think it compares? Do a little math in your head. What are you thinking, Brady?
She weighs twice as much as Snow.
So Klondike weighs twice as much as Snow. So that's Brady's prediction. So then thinking about the fraction, what fraction would Snow weigh compared to Klondike's weight? 1/2. Ooh, I'm thinking Brady's on the right track. So it shows us that Snow's weight in pounds versus Klondike's weight in pounds. So Snow's weight in pounds is what position on the fraction? The numerator. That was kind of confusing. So then Klondike's is the denominator. So it's showing them a comparison from top to bottom. So in the chart below that you can see 450 pounds is 1/2 of 900 pounds. So Brady's prediction was correct. So it shows us down here different increments of weight. So 0 to 150 to 300 to 450, all the way 600, 750 to 900. And it shows us that 450 is in fact 1/2 of 900. So Snow weighs, just like Brady told us, 1/2 of